So this is a summary of what we've been doing. Here we want to look at equation with no solution. When an equation has no solution, then we will notice that that their the constants will be equal. For instance, let us look at this question. They say if the linear equation above has no solution, which of the following could be the value of b? In this situation, all you need to do when it has a solution, you know that their constants will be equal. So let's expand this. 4x plus 13 is equal to 7x minus 14 plus bx. Now, as I said, when it has no solution, the constants will be equal. This will not be equal. 13 equal to minus 14. They are not equal. 7x plus bx will have to give you 4x. When it has no solution, the slopes will be the same. Okay, but the intercept, which is the constants, those constants here, the intercepts would not be the same. The intercepts are not the same, but the slopes are the same. The intercepts are not the same when it has no solution. So all you need to do is solve this. The slopes is whatever is with x. So 4x plus 7x plus bx. So this 7x plus bx should give you 4x. So that's b should be minus 3x. 7x minus 3x will give you 4x, and that's what plus 13 is not equal to minus 14. So that is your answer, minus 3 here. So remember, when an equation has no solution, the slopes are the same but the intercepts are not the same. Another thing is that when an equation has infinite solution, we'll get to that in the next segment, still on this video or very soon. Now, when it has when the equation is an identity, such as this, when it's an identity, we say that the slopes are the same and the intercepts are also the same. Say that it's an identity, they will be equivalent when it's an identity. So he said if the linear equation above is an identity, what is the value of a? So we simply expand this. We'll be having this is 15 over 3, which is 5, minus this is 6 over 3, this is minus 2x is equal to 5 minus ax. So we see that this 5 here and this 5 are the same. Minus 2 here should be the same as minus a here, because x and x are the same. So minus 2 and minus a, what would that be? That means a is equal to 2, and that's it. So when it has an identity, they're equal. Let's look at what about this one. What's the value of this? 2c square a square minus 10 times b plus c. Now it's important to remember your bead mass when solving algebra like this. Remember your bead mass, okay? And in your bead mass, you should do the brackets first before the I, then d, the m, and the a, and the s. Now remember, the d and m have equal precedence, and a and s, that's addition and subtraction, have equal precedence, and you do them from the left to the right. So we're going to work on that. Know that everything you do on board bead mass is going to show here. Okay, so the first thing you do is your brackets. Where are your brackets? This is b plus a. You cannot add this, or you can square this. But actually they have given us some the option, some of the of them to substitute. So we're going to substitute into this for the bracket. We're going to solve b plus a, and b is 3 plus minus 2, which is 3 minus 2 will give you 1. So you have 1 here. So let's write that out. Real quick. And now that's 2c squared. Fine, let's put this 3 minus 2, which is 1. So we did 3 minus 2, which is 1, over c is 5, 1 over 5. I have 10 times that minus, so 2c squared, this is 2, we are going to raise the power 2, so 5 here, 2 times 5, 10 raised to the power 2 is 100, and then a is minus 2 raised to the power 2 is 4. Okay, so now we have this minus 10 times 1 over 4. Now some persons may wonder, what are they going to do? Are they going to do 100 minus 10 first? 100 over 4 minus 10? No, you're supposed to do, with your bead mass, you're supposed to do your multiplication. So it's 10 times 1 over 5. That will give you 10 times 1 over 5. That's 2. And then this is 100 over 4. What's 100 over 4? 100 over 4 would give you 25. So you have 25 minus 2. And the answer is 23. So clear that. Now it's also, we're also going to consider what functions are. One of the summary. When we're talking about functions, we're talking about the relationship between x and y. So when you give a function, we're just simply talking about if they say function of f of x is equal to whatever they say, blah 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 blah, equal to whatever they want to do. Okay, it's the same thing as saying y is equal to whatever it is. And your functions, you have different types of functions. You have your linear functions, okay, and you have your quadratic functions. We have polynomial functions of powers more than 2. So when talking about a coordinate plane is formed by the horizontal line called the x-axis, and another name for the x-axis, the abscissa, and the vertical line called the y-axis or the ordinate. So they meet at the origin, which is 0, 0 here. The axis divided into 4 planes, and each of them are the quadrants. So remember, when they talk about the quadrant, these are the positions of the quadrants. Okay. A relation is set of ordered pairs. A relation can be presented by a graph. You can represent a graph by a graph or a mapping, and the x values and the y values are those points. There. Now another thing to remember is that a function can only be a function if there are 2 values of x or 1 value of x to a value of y. There cannot be 2 values of y for 1 value of x. If there are 2 values of y to a value of x, that means that is not a function. So remember that. We're going to talk about why which one is a function and which is not a function. Now, how we know what a function is and what a function is not? Now, if you look at this, all we need to do is a vertical line test. Stretch a line across whatever graph they give to you. Just make a line across. If it cuts more than 2 points on if that line cuts, if that's your curve or anything that you're doing cuts more than 2 points, that means that thing is not a function. So you just simply draw. For instance, you draw a line here, like what they did here, and you see it only cuts at 1 point. Here, when they draw the line, it cuts 2 points, and that means it's a what? It means it is not a function. That's how you can easily get it. Another thing you should know is that if you're having something like this, x is equal to y2 minus maybe y anything more than 1 value of y. Sorry. We have like this graph, for instance, is a graph of the function of x, not of y. So it's not it's like a x. It's like x equal to something. X equal to related to the values of y. So it's quite different. It's not like y equal to what we know, y equal to x squared plus anything from a quadratic or a linear function. So that's how you can test your for if there is so if something is a function or is not a function. So when we're looking at this is what we're talking about, equations or functions that can be written in function notation. So we say y equals to 2x plus 3, same thing as saying f of x equals to 2x plus 3, and that's it. So if you have f of 2, you just simply plug it in, and that's whatever you see is your answer. Now let's try one question, a little question. Let's look at kind of what we're talking about. It said at point 7, b is in quadrant 1, and point a, minus 3 is in quadrant 3. So from this, we know that 7, b is in quadrant 1. So it's at this point here. Now at this point, y and x are positive. So b is positive. B is positive. Okay. Then point a, 3 is in quadrant 3. This is quadrant 3 here. This is quadrant 3. So if it's in this quadrant, a and a, minus 3, so minus 3, x is negative at this point. So a is negative, and minus 3 is y. That's my y there is minus 3, and minus 3 is negative. At this point, both are negative. At this point, both x and y are negative too. So when they say a, b, well, we know that a is negative here, and this one b is positive. The only place where x is positive is actually negative. X is negative and y is positive is in this quadrant here. It's in this quadrant here. In this quadrant here, you see x. In which quadrant is the point a, b? Okay, where is it? In which quadrant is it? So we know that a is negative. We know that a is negative, but b is positive from what we have done here. If b is positive, we know that y can only be positive anywhere above this place. But where is x negative? X can only be negative in this point. So we have quadrant 2. The answer is quadrant 2. Let's move on to the next one.